Alright, so welcome. I'm going to do a quick video on solving inequalities with quadratics. And this is actually a kind of neat topic. When we're going to solve an inequality with a quadratic, we're going to do everything fairly similar to when we solve a quadratic, a quadratic that's not an inequality, that's an equation. And so what I'm going to do first is I'm going to make sure that's set equal to 0, and it is, so that's good. And I'm just going to factor. I'm going to say, well, I know that this is going to be... oops, sorry. Let me rewrite my question. It should have been. We're going to start with a question that actually works. X squared plus 2x minus 15 is less than or equal to 0. So if I have x squared plus 2x minus 15 is less than or equal to 0, I say, well, that's going to be x plus 5 and x minus 3, and it's still less than or equal to 0. And you run into a little bit of a problem now, because if this was just an equation, what we'd do is we'd set each of them equal to 0, and I'd say x plus 5 equals 0, or x minus 3 equals 0, and say x equals a negative 5, or x equals a positive 3. The problem is, when x equals negative 5, this does equal 0, so that's one solution. When x equals positive 3, this also equals 0, so that's another solution. But the problem is, this is an inequality, so we want to actually find out when they actually equal are less than or equal to 0. So what I'm going to do is I'm going to put down a little negative 5, I'm going to put down a 3. And one of the things I think is kind of neat about this is you can use a little chart, and I'm going to get rid of this line for now. And the chart looks like this. These are what I consider my goalposts, and I'm going to say, all right, negative 5, I'm going to write 3, I'm going to put down a little goalpost there. And what I'm going to do is I'm going to say x minus 3 as one of my values, x minus 3, and then x plus 5 is another value. And now, what this area here represents to the left is are all values less than negative 5. So I'm just going to pick some value for that's less than negative 5. I'm going to say negative 10. If I plug a negative 10 in for x, I'm going to get negative 10, negative 13, or negative 3, which is a negative 13. And x plus 5, if x is negative 10, that's going to be a negative. Now take a look. Here, I'm multiplying this with this. And if I multiply a negative times a negative, I end up with a positive. Well, a positive value is not going to be less than 0. So that's no good. Here, if I pick some value between negative 5 and 3, let's pick the value 0. So here I picked negative 10. Here I'm going to pick the value 0, because it just has to be between negative 5 and 3. If x is 0, 0 minus 3 is a negative, but 0 plus 5 is a positive. Now once again, that means this times this. Well, if I have a negative times a positive, that's a negative. And that would be less than or equal to 0. So I'm going to try one more value. I'm going to say, well, what if x was, let's say, positive 5? All right? Because it just has to be greater than 3. And I think you'll notice that if I were to use a number line, positive 5 would be someplace here. 0 would be someplace probably around here, and negative 10 would have been someplace around here, right? So these are all just values that are in between my, like I said, my goalposts. Here's a goalpost, here's a goalpost. They're not actually called goalposts, that's my own terminology. If x is 5, that's going to be a positive 2, which is positive, and that's going to be 10, which is positive. And so my product, my entire product, would be positive, which is not less than or equal to 0. So you can see the only time it works is when it's negative, because a negative value is less than 0. And so that means all the x values between negative 5 and 3. Well, this was less than or equal to, so I'm going to use my brackets. And I'm going to show that this is my solution. So it's going to be on a number line, look like that. And so it's be, those are all my solutions that make this inequality true. All right, I'm going to do one more. So I'm going to erase all of this. And I'm going to use another chart. And you're going to see why in a moment. I'm going to erase all of this. And, oops. I rather like that dark blue. I'm going to do it in the lighter blue. So once again, here you might say, oh no, it's a quadratic where a is greater than 1. It's not a problem. Let's see what we can do. I'm going to try to simplify this, or factor it rather. I'm going to say, all right, well, 2x squared. Now let's say 2 times 12 is 24. And so my factors are 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. I'm going to use 3 and 8 because that will get me to 5. So I'm going to say 2x squared, let's say minus 8x plus 3x minus 12 is greater than 0. And once again, I want you to understand the reason why I do this is because if I multiply 2 times 12, that's where I got my 24 from. Negative 5x, I rewrote as negative 8x plus 3x. Negative 8x plus 3x is negative 5x. So if you take a look, these two are the same. They're just written differently. All right. So I hope that does make sense. I'm going to try to clear some of this up. And so now I can remove a factor here. I get x minus 4. Here I'm going to pull out a 3. And I get x minus 4 greater than 0. So now I get here are my two groups. I'm going to factor out an x minus 4. And that leaves me with 2x plus 3. It's greater than 0. Now, once again, I'm going to set each one equal to 0. And that gives me an x equals 4. If you're not sure, I'll show this one out. And so I get 2x equals a negative 3. I get x equals a negative 3 halves. And so those, once again, these values, when I plug them into this initial equation, my original equation, will equal 0. But I want all the values that are greater than 0. So I'm going to make my number line. I'm going to put a negative 3 halves here. I'm going to put a 4 here. And I'm going to make a little table. Maybe I should try and do my table a little bit nicer this time. Make it look a little bit more professional here. Here's 1, 2, 3. All right, get rid of my ruler here. All right, so here's my, no, I probably should put in one more. There we go, a little bit better. So let's say if I put my 4 here, my negative 3 halves here, I'm going to say, all right, this is x minus 4, and this is 2x plus 3. Now, I'm going to pick some value that's less than negative 3 halves. And the nice thing about this is you can really pick anything that's less than negative 3 halves. So I'm going to say, how about negative 6? And if x is negative 6, which would be someplace back here, that's going to represent everything that's less than negative 3 halves. So negative 6 and a negative 4 is a negative 10. Negative 6 would be 2 times negative 6, which is a negative 12, and negative 12 and a positive 3. Even if you're not sure what it is, you should just recognize that a negative 12 and a positive 3 is going to be negative. And when I multiply a negative, which would be here, and a negative, I'm going to get a positive. Now that's good because I want my answer to be greater than 0. And anything greater than 0 is positive. All right, so now I pick a value between negative 3 halves and 4. And once again, I always choose 0 if I can. So 0 minus 4 is negative. 0 plus 3 is positive. A negative times a positive is a negative, which means everything between negative 3 halves and 4 should yield a negative value. And then finally, I pick a value greater than 4, let's say 1 million. That's going to be positive, and that's going to be positive, and that's going to be positive. And so if you want, I can write down product. And these are the ones that are really important down here. And so that means anything that's greater than 4 will yield a positive answer, and that's fine because, remember, I wanted it to be greater than 4. So it's going to be open parentheses on the 4, it's going to go that way. It's going to be open parentheses on the negative 3 halves, it's going to go that way. And that's what my number line would look like. My actual solution set, that's from the last problem, would look something like, not solution set, be negative infinity to negative 3 halves, parentheses, or 4 to infinity. And that's it. I hope that you understand what we're doing, first of all, but also how to use this table and how to use the number line as a guide. All right, you might be able to do it just using the number line. The idea is understanding that we are looking at the product of the two factors and how that influences whether or not it's greater than 0 or less than 0. Hope you enjoyed. I enjoyed making this, and that's it. Thanks.